is now starting. All attendees are in listen-only mode.
Most of the time, we make decisions about innovative, new initiatives or new technologies that come in the world by making an investment.
by making an investment.
It's coming back. Feedback is coming to me.
It's coming back. Feedback is coming to me.
How to unmute.
I have to unmute. So, so we look at new technology like a heat pump, evaluate whether it is suitable for us or not, do a technical study of what will be the size that will be suitable for us, make an investment, thinking that there will be a 2 years payback, 1 year payback, half year payback, or whatever, make an estimate of what the payback is. And more often than not, after you make an investment, let's assume that we make an investment thinking that it will save 50% of our energy. After we make an investment, it's a sunk cost. There's no huge incentive for anyone to go back and measure whether it is provided that saving or not. What are we going to do if it's not providing you that saving? We are already made an investment, so we live with it. If it doesn't work, we ask the company to service it, but otherwise we live with whatever savings are there. Is there any other way by which we can try before we buy? After all, proof of the pudding is in the eating. Till we test it, we don't know whether it will work or not. But majority of the innovative equipment suppliers are small companies, startup companies. They can ill afford to give a test base or a trial base. Aspiration Energy, through an arrangement with a financial partner, is today in a position to give you a way by which you can try a 28 kilowatt heat pump, paying just half the rent. What is more, you don't even have to buy the heat pump at the end of the trial period. You can continue to rent it for as long as you wish. And you can also send the machine back, equipment back, if you don't like it with a 3 months notice, after the trial period is successful. Now, how does it work? Does it suit you? Is it okay? There are many questions that are there in the trial offer, and let's attempt to answer them during this session. First of all, what are heat pumps? As Priya mentioned, there is very rudimentary understanding of what a heat pump is across the world. While air conditioners have been used forever, chillers have been used forever, for more than a few decades. Heat pumps are fairly new phenomena in a large scale. They have been used in many applications, but in a large commercial scale, in mainstream applications as a heating alternative, is fairly new. Fundamentally, if you have had an experience with any air conditioner or even a refrigerator at home, you will understand that heat is taken away from inside of the refrigerator or from inside the room and thrown away outside. Now, Priya was mentioning that heat pump is a reverse of a refrigerator or a chiller or an air conditioner. What we are doing is to capture the heat that is thrown from inside, and that hot side. So if you have a split air conditioner, you will find if you have walked near the outside unit, you would have felt a heat. Now that heat is what we are trying to use. So there is always a cool side and a heat side. The cool side is the evaporator and the hot side is the condenser. And the transfer of heat happens through provision of compressor and expansion valve in between the evaporator and condenser. So the evaporator provides the cool side, the condenser provides the hot side. In a heat pump's case, the useful energy is delivered by the condenser. So we are interested in heating, so we are interested in condensing, and the heat is thrown out or the cooled or the heat is absorbed by the evaporator side, which is kept outside the application. So we keep the condenser inside wherever you're getting heated. So for example, if it's a bath, hot bath, we keep the condenser in the hot bath side and keep the evaporator on the outside. That's basically what heat pump is. Majority of the heat pumps in the world are using vapor compression refrigeration cycle. There are many other refrigeration cycle. We will not get into that. But the fundamental idea, why do we do all this? What is it in it? What is in it? What is there in it for us? The fundamental idea is when you must have, if you have a split air conditioner near you, the inside unit, if you have an air conditioner in your home, or if you have a chiller, you can go and look. Of late, the consumer appliances have a label, BE label on them. If you look at them, they will have 2-star, 3-star, or whatever, but below the label, there is a number that says 2.0, 3.0, 3.5, 5.0. What is that number? That number is what we call as COP, coefficient of performance. And what does that mean? That means that for transferring that many units of heat from the cold side to the hot side, you are spending only 1 unit of electricity. So in effect, heat pumps multiply electrical energy, but energy can never be created or destroyed. How can it multiply? It actually does not multiply. It uses 1 unit of electrical energy, but it draws 2 or 3 more kilowatt hours equivalent of heat energy from the atmosphere at the evaporator side and supplies that as heat in the condenser side. So for every 1 unit of electricity that you input, you get multiple units of usable heat energy. That is the COP. In an air conditioner, that number that is mentioned below the BEE mark is the COP. In heat pumps, it is similar. So you give 1 unit of electricity, as you can see in this diagram. You collect 2 or 3 more units of ambient heat and give it away into the heating side, and hence the cost of heating per unit of heating becomes much cheaper. If you have to use on the right hand side the usable energy using an electric heater, you will have to provide all the 3 of heat energy that is required in the form of electricity. Whereas when you use a heat pump, you provide only 1 unit of electricity, but it collects 2 units of heat from the ambient and provides 3 units of heat. And hence it becomes extremely economical. In many cases, it is even comparable to, in terms of cost, to cheap fuels such as furnace oil. But this is much cleaner because for producing same amount of energy, you will have to burn as many units of furnace oil. Whereas here, even if the electricity is produced by unclean fuel like coal, you will be consuming only 1/3 or 1/4 of the coal to produce the same amount of energy. The remaining is got indirectly. We call it as passive solar many times. Fundamentally because what is the source of ambient heat? The source of ambient heat is solar. So in essence, this is kind of a solar heater. We call it as passive solar heat. 1 unit of electricity is consumed from the grid, but 2 units of solar energy is consumed from the ambient, and that is what contributes to the heat delivered by the heat pump. So the costs can be very, very low. Now, where can this be applied? So far, we have applied heat pumps in any hot water applications up to 70 degrees centigrade, including plating, any kind of washing, We are supplying it in pre-treatment, degreasing. We are working with some applications like hotels and hospitals where hot water cleaning, hot water bathing, dishwashing, or washing of clothes. These are some of the applications that are there for heat pump. Now, the difference between an active solar collector, like a solar module or a solar heater that you have seen, and the heat pump is that solar hot water generator can work only when the solar radiation is there, because it's collecting the radiation heat of the solar or sunshine. Whereas the effect of sunshine on atmosphere is there even during the night, functions as a heat, and hence the heat pump can work 24/7. While solar can only be taken as an addition or substitution whenever sun shines, heat pump can be easily applied as a primary source, because the heat pumps, because of the several decades of experience in chillers and air conditioners that we have in the world, the heat pumps are extremely reliable devices, very easy to maintain because there is trained resources available everywhere. People who know how to service chillers, who know how to service condensers, who know how to service the evaporators. People know how to service compressors or replace compressors, how to control this entire refrigeration cycle, because large chiller systems or small air conditioning systems are prevalent in the world for decades. So, because of their reliability, they can be operated 24/7. So, thermal systems like boilers, furnaces, induction heaters, and hot water generators can be totally replaced as a primary source of energy by heat pumps at a much lower cost. Because any boiler, let's say it's a LPG run boiler, it will consume the direct equivalent amount of LPG for heat delivered, whereas heat pumps is going to consume only one third to one half of the energy required to generate the same amount of heat. So that's the fundamental. Can we look at some numbers and understand the perspective of this? So if you really look at this 28 kilowatt heat pump that we are offering on a rental for 3 months of 12,500 trial offer, the expected saving is an average of 40,000 rupees a month. The expected saving is in the average of 40,000 rupees a month. How does that work? If you're utilizing on the vertical side, the percentage utilization of heat pump 7 by 360. There is a lot of that load versus meters, or if you rate the rated capacity of the point two or point. So let's say you have a heater will not, it will run for 40 is attained. Pump will continuously deliver kilowatt. We have to look there in the horizon. The rules represent electric heater could be 36 kilowatt. If it's a rated capacity of 50 kilowatt heater, usually the average load will be 25 kilowatt. That's what we have seen in the industry. But this is a number that somebody has to evaluate and tell us whether it is right or wrong. On the ROO is the percentage utilization. As you can see, at about 50% utilization, if you're going to be utilizing the heat pump for 365 days only for 12 hours or 24 hours only for 184 days or something like that, then it's a 50% utilization. The revised rental at the end of 3 months trial will become 25,000 rupees for this heat pump. Only 20 kilowatt and above at 50% will become economical. Anything below 20 kilowatt, if you're utilizing the heat pump only for 50% of the time, will become uneconomical. Same way, if you're using it for normally, let's say 80% of the time, which means, let's say 300 days, only for about 19 hours or 21 hours or something like that. If you're using it for 80%, the savings at 18 kilowatt average load is 36,000, at 25 kilowatt average load is 50,000. So it depends on how much load you're consuming and how much percentage of time that you're utilizing. As you can see, a 25,000 rupees rental is economical for most of the cases, above 20 kilowatt with 50% utilization or any kilowatt above 60% utilization. That's the fundamental. An average of 40,000 rupees a month. You will be paying a 25,000 rupees a month rental on this heat pump at the end of 3 months. And what do we accomplish in the first 3 months? What we are accomplishing is we can go into great lengths to measure the average kilowatt. We can go great lengths to measure the average utilization. That will depend, average utilization will depend on your load, average load will depend on time of the day, because in the night time the outside air is colder and hence you may need extra heat. It will depend on the load, it may depend on the demand of production from your end, all of that. We can do a big analysis to understand what the exact economics is and come back with payback periods and all of that. But what this rental offer gives you is, as long as you know that you're in this ballpark, you're utilizing, you should try it for 3 months. Savings we have, and so we know if the saving is big, so take it back, because you're paying only 25,000 rupees rent. You can also buy the heat time to enjoy and go back to your normal paradigm of this is tried and tested. You know that it is proven, it is working. Once you are convinced that it is saving more than 25,000 rupees by pure measure, now you go back and either continue on rental or buy the heat pump. And if it doesn't work at any point in time, you can return it back. At the end of the day, this is a very good thing, because your production situation may be very high today. 6 months later, your production comes down, and hence the average kilowatt is coming down, or the percentage utilization is coming down. So the 25,000 rupees is more expensive than your primary fuel. Take it back, buy it back at every point in time. So numbers behind the rental offer. And the trial of is this tried and tested. We already have about 17 installations across large industries like Ashok Leyland. We have a 28 kilowatt thermal nominal heat pump that heater in engine head washing in Ashok Leyland at Ennore. The present consumption is only 12 hours per hour, delivering about 25 kilowatt. So they are saving about 86,400 kilowatt hour. Their electricity consumption was 24 kilowatt hour. They are using it for about 16 hours a day, and it's very economical for them, and they are very happy about it. We did a small trial similar to what we are offering. We replaced a 14 kilowatt carburetor washing electric heater with a 14 kilowatt. Average electrical consumption is only 6.34 kilowatt hours. The energy saving is more than 46%. This is without even doing the full-fledged installation, only during trial where the insulation and exact matching and all of that were not done. We got a very good appreciation letter from UCAL Fuel Systems for the savings will be even higher than this. This is the kind of, I wanted to show this photograph to you to make you understand what this is. This is what is on the left is the heat pump. The heat pump will require some kind of a heat exchanger system before it goes into the process. This is our installation. The rental offer is on the heat pump. We can integrate it directly, or we can go through a heat exchanger in between. And once we implement the system, we will measure the temperature to give us the amount of electrical heat of not have a system. Sometimes people do, but here of what the amount of what energy, we know the cost of electricity, we know the cost of fossil fuel based heating. It was so. At some point, the LPG cost was lower compared to electricity cost. Electricity has not inflated as fast as the fossil fuel has inflated. If you take LPG in the last 10 years trend, you will find that LPG has inflated much more than electricity. There were two reasons why fossil fuels based systems were put up by many industries. Some of you may be aware, some of you may not be aware why fossil fuel based heaters were put up instead of electrical heaters. One, the cost of electric, but in the last 10 years, that situation has changed clear in many cases because of one, inflated costs, number two, efficiency of the boilers. Usually the boilers and hot water generators are put up for capacity of startup, but during running, when they are maintaining the temperature, they are running only at about 30%, 40% load. Now at 30%, 40% load, they are only about 55, 60% efficient, and hence they are consuming more fuel than what we envisage as calorific value of the fuel. And hence the effective cost of heating, because of these two reasons, is more expensive in fossil fuel today than electric. Shortage of demand, huge shortage of electricity. Today that situation has changed. Many of the states have surplus power. With wind power and solar power coming in, it is becoming better by the day, and hence today electrical heaters themselves are more economical than fossil fuel based systems. If you put an electrical based heat pump system, which consumes only half or one third of the energy required, then the demand is also lower and it is cheaper to do heat pumps. In many of the cases, even fossil fuel based systems can be very easily replaced. But when we are offering the savings, when we are computing the savings, we'll assume that the saving is in electricity and tell you, make sure that we are understanding and rate of our rental scheme. We want a 10-month, 12-month contract. This is based on an arrangement with our financier for only 10 heat pumps to be signed 28th of February. It's a 28 kilowatt heat pump. We give it on a rental of 12,500 per month. The cost of transportation and integration will be to your account. You'll have to provide the piping away from the heat pump to your heat source. I mean, your heat utilization point and all of that. You will have to make that investment. You can cancel anytime within this period if the savings are not affected or the heating is not enough or whatever. Because we are not doing a very detailed evaluation. We are just saying it's a ballpark range and it's a ballpark utilization. So it may not work for you. After 3 months, the rent will revise to 25,000 rupees a month. You have a 12 months contract, and the contract can be broken anytime with a 3 months notice, and you can buy the heat pump anytime. As I mentioned to you before, we measure the heat pump outlet and the heat pump inlet temperatures. We also measure the flow, and that will give us an idea of how much heat we are delivering. We also measure the electricity consumed by the heat pump. Hence, we will know what the saving is, and that's what we will use for computing the savings to determine whether the savings is about 25,000 rupees or not. We are setting up a live demo of this 28 kilowatt heat pump unit at IIT Madras. We will come back to you once that is ready, and we request you to consider this as a great opportunity to try a new technology. If it doesn't work, what are you risking? You're risking only 12,500 into 3, maximum 37,500. If it works, you're paying less than what you're saving. So you should be a very easy decision. We have 10 heat pumps on offer. I hope many of you will avail it. Thank you very much for taking your time away to listen to this webinar. I look forward to questions and I'm ready to answer the questions.
Mr. Anand Marathe has asked one question. Our heat pump is 100% indigenous or not?
Wonderful question. Thanks for asking that. No. At this point in time, other than the sheet metal not made in India, compressor manufacturer compressors, the volume is most critical part. Even the condensers and the evaporator, we are doing evaporate. Those are not made in India right now. There are manufacturers who claim that they are manufacturing in India, but fundamentally they are only doing the sheet metal fabrication and assembly here. All the components are mostly imported either from Korea or from China, and that's a case worldwide. These are components. Compressors are not things that can be manufactured at low volume, and bluefin evaporators are made by some people in India, but not a whole load that suits a heat pump. So majority of this is imported. The next question is, what will be the transportation cost to deliver at locations like Mumbai, Pune, Chandigarh? I don't have a ready answer for that. It should be in the, I think it will be in the 5 to 10,000 rupees range. That's what my guess will be. The next question is, will it work for hot water requirements of industrial scale dishwashers working for 250 days single shift? As I showed you before, I'll go back to the show you. The utilization is okay. When the utilization is below 50%, which is single shift for 250 days, obviously is 1/3 for only about 2/3 of the days. So we're talking about less than 25% utilization. It will work wonderfully technically, but it will not be economical because it will go below 50% utilization. Even, I mean, below 50% utilization, even at a 25 kilowatt, which is a maximum load, the savings will only be 31,500. When it is less than 50%, it will become less than 31,500. So the savings will not be substantial. So rental offer for that will not be that economical because the rent is 25,000 rupees a month. If you buy a heat pump for that purpose, depends on your current cost and the efficiency. We don't know what that is. Assuming that it is very efficient, the payback periods can be upwards of about 3 years or so for that kind of utilization. Heat pumps, because of higher initial costs, can be justified only if you're utilizing for more than 60-70% of the time. During the contract period of 3 months, if equipment malfunctions, what is the backup to run the output? That's another question. Wonderful question. I am not anticipating that while we are supplying the 3 months itself, you will, if you already have an existing arrangement, you will replace it. If it's a new application and you are using heat pump as a primary source, we strongly recommend a backup electric heater of the requisite capacity to back it up if the heat pump is malfunctioning. Having said that, the availability of heat pump is upwards of 98%. I mean, I'm just taking a very conservative figure of 98%. They are rated to work for 99.5%. But I am taking conservatively a 98% availability of heat pumps. Heat pumps are like chillers. I mean, they don't fail that often. We may have to maintain them a month, shutdown of 2 hours or something like that, 3 hours too. That again is not necessarily for servicing any components of the heat pump, but to service the components of the fluid transfer. Many of you will be familiar with the maintenance issues with respect to transmitting hot fluids, thermic fluids, and hot water lines, filter mechanisms, and the sealants. Those are the parts that fail, and so those are the ones that need to be maintained periodically. So if the equipment malfunctions, we need to provide for an electric heater if that is a primary source. Do we get an additional output like cold water or cool air as well? Absolutely. I'm very happy to get this question. In case of one of our installations, what we have provided is a shroud, which has become like a cool zone in the factory. So we have provided a AHU and a small shroud near the water filter and breakout area. So people come there to cool off. It's an additional thing. In another installation that we are doing in Lucas TVS right now, what we are doing is to take the cold output and giving it to the cooling tower. What that does is reduce the load on cooling tower and hence reduces the consumption of cooling tower. So in case of hotels and hospitals, What we are actually doing is to provide a supplementary air conditioner to their existing centralized air conditioning unit, and that is a direct benefit for them because to that extent chiller load is reduced. So in case of a factory which does not have a cold water nearby, then we can only provide a cool zone or something like that. The output on the cooling side is in the 15 degrees to 22 degrees range, and hence it cannot directly replace a full-fledged chiller with 10 degrees, 9 degrees, and so on and so forth. This is a 15 to 20 degrees kind of cooling. What is the heat pump kilowatt? Now, the heat pump kilowatt is a nominal output. When you say nominal, we are measuring it at 25 degrees ambient. We are measuring it at 25 degrees ambient at 100% load. Is what we most of the rating of the heat pumps is, while it can be theoretically calculated based on condenser design and compressor pressure and all of that, usually heat pumps are rated using empirical sphere. In factor the V sphere, where we create the situation of output of heat pump.
HWS. I mean, he's saying solar hot water system.
Can it replace a 6000 LPD solar hot water system?
Yes, this is up 600 liters per day. This 28 kilowatt system is approximately 600 liters per hour. I'm sorry. That is the approximate number to be delivering at about 70 degrees. And hence, it can easily replace a 6,000 liters per day hot water generator using solar, because solar has to generate within 6 hours, whereas heat pump can work for 24 hours. So it can easily replace a 6,000 LPD solar water heater. I will. Kumar has one more question, and that I will take it offline because it's not relevant to this webinar. But we definitely will separate brand called Assured Heat, and we sell and service. I mean, actually, we service heat pumps made by other manufacturers, because heat pumps are not serviced extremely well, and so we also service heat pumps and solar water heaters supplied by other manufacturers as well. We have the requisite expertise to do that. So even if some heat pump is available and that's not integrated extremely well, usually the heat pumps will work very well, but the integration is a challenge. Solar water heaters also the same way. The solar water heaters will be okay, but integration will be a challenge. We'll be happy to address them. We'll be happy to service them. Is it only lease rental or capex option is available? Absolutely, capex model is available. We are, I mean, at the end of the day, We are in the business of selling and servicing heat pumps. Absolutely, capex model is available. But for those who do not understand what is heat pump, who want to try it before they buy it, we are offering a special offer in arrangement with a financial partner, a rental offer. Any accelerated depreciation, absolutely. Heat pumps attract accelerated depreciation of 40%, and manufacturing industries can claim an additional 20% depreciation as modernization of their manufacturing equipment. So in the first year, you can claim 60% accelerated depreciation for manufacturing industries. Do we supply heat exchanger, or we restrict ourselves only to heat pump and storage tank? We are not manufacturer of heat exchangers. We work with companies like Alpha Label and Thermex to provide heat exchangers. But we usually we prefer a turnkey solution where we take up the entire design and installation, because that way we are single-handedly answerable to the entire working of the system. But sometimes the customers prefer doing part of the integration themselves, in which case we can restrict ourselves to heat pump. But our preference is to do the complete system. And our preference generally is not to put the condenser an intermediate circuit. With the expensive heat, maybe sensible to have a heat exchanger in between for maintenance purposes, as I showed you in the UCAL installation. Here in the UCAL installation, we did the entire installation, including the heat exchanger, everything, installation of the circuit. But this is a skid, transferable skid that we designed so that we can transfer from one place to another. Two more questions? Oh, okay. During efficiency, but during nighttime balanced 12 hours, how can it be equal to day hours? Also, is it okay to use our boiler feed water temperature is 70 degrees centigrade? So, number one, 50% utilization during daytime will give good efficiency, but during nighttime balanced 12 hours, how it can be equal to day hours? Now, the temperature difference and the sensitivity of ambient temperature to the efficiency. Ambient temperature changes from daytime to nighttime, let's say by 10 degrees. The COP will change by, let us say, flavoring at COP of, let's say, 3 in 2.8. Vast, it's right, but to 3.0 COP, and during the night it will deliver 1.5 COP. It's not like that. It is only 1.1.2 difference in COP. That is because at the end of the day, temperature, the evaporator inside temperature, the temperature difference is only affecting the amount of heat exchange area available. It is not affecting the amount of energy absorbed. Amount proportionate to the amount of fuel that is there, or the amount of refrigerant that is there inside the system. Amount of the refrigerator should be absorbed. So it is not dependent on the atmosphere surface area available, but as much amount of the heat pump, it will absorbed the quantity on the is it water temperature? Our heat pump that is on offer